interact with us through Twitter on AI Kenya 1. The hashtag for today's event is MLOps, hashtag AI Kenya. So AI Kenya is a community of practitioners and enthusiasts in artificial intelligence and its related technologies. We started all the way in October 2017, so we should be celebrating our 6th-year anniversary this year. And we mainly come together to engage, learn, grow, and stay informed on all matters and topics related to artificial intelligence. So when we're talking about AI and its related technologies, we are talking about data analysis, data engineering, data science, robotics, machine learning, and data visualization. And on the other side, we also focus on non-technical topics such as data privacy and data protection. So our community is both for techies and non-techies. We focus on beginners, intermediates, and experts. We exist majorly to democratize machine intelligence, which means we are making AI accessible to everyone. And we see ourselves as an enabler and ecosystem builder in the Kenyan tech industry. So how we achieve this is by enabling and building a thriving AI ecosystem where people can learn, grow, engage, and stay informed. So by Learn, we have different programs where we want our community's members to build and advance their knowledge and skills across different topics. And we do this through Code Maktaba, show and tell, mawaidha sessions, hackathons, and documentary screenings. For growth, we focus on connecting community members to different opportunities in machine learning, data science, and other fields. And we do this through our website where we share job opportunities, internships, scholarship programs, research programs, and so on. And then we also encourage our community members to engage and interact with each other. And we have a Slack group, we have a WhatsApp group, we have a Telegram group where community members can interact with each other and share information. And we also have our pillar of making sure that community members are always informed. We do this through a monthly newsletter, our YouTube page, and we also have business interviews, podcasts, and event videos, which we share on our YouTube page and Facebook page, which community members can interact with. So the spotlight on today's topic is machine learning operations, where the talk for today was to give an expert or a practitioner who is already in the field to share more about this field that is very important in the entire pipeline of building and shipping machine learning projects. So today we are majorly going to gain more insights on efficient building of machine learning projects, how to optimize and streamline the delivery of machine learning and data science projects, and then a bit on how to venture into this field as a career. So as we go through the event, you can share your questions on slido.com, and then you use the code AIK26 to share any questions you have, any comments you have regarding the event. So at this time, I'd want to welcome our speaker for the day, Kevin Karobia, who has been a community member with AI Kenya for a bit of time right now. He'll tell us more about himself and his relationship with AI Kenya, what he's doing now, and then take us through his session. So Kevin, welcome, and you can take over and share your screen.
Okay, so yeah, and so I'll try and confirm that you can see my screen, right? Oh, okay, so I think let me just remove the slideshow. Okay, so yeah, my name is Kevin Karobia. Yeah, I'm Kenyan, born and raised. I have my crew over here. Yeah, and yeah, I'm currently working as an MLOps engineer at Datatonic in London, UK. And yeah, today I'm going to give you guys a talk about MLOps and what it actually entails and how you can break into this particular field. And yeah, so a little bit of myself. I'm a JQuad alumnus, go Juja boys, from the College of Engineering. I did my bachelor's degree in electronic and computer engineering. And yeah, was fortunate enough to graduate, which, I mean, get a degree in Kenya is always a tough ask. So I want to move this around. And yeah, so I started seriously writing code. By seriously writing code, I mean, I had actually tried writing code a bit before in second year, and I had started with Java. And luckily, Java didn't stick, and yeah, Java wasn't really my strong suit. So in my third year, I decided to learn Python. And first of all, the syntax of Python is relatively easier to grasp. Yeah, and I think I forgot one bit here. So I'd like to thank the people in attendance. I think my line manager is in here. It's been live streamed, so I can't really tell the participants. And of course, a shout out to my family, my brothers, my sister, and my mom. I'm sure they're all listening in. Yeah, so started seriously writing code in my third year. Started with Python. And then like for most of that particular third year, I think this was around 2016, I believe. Yeah, 2016. That's when I started writing code actually. And took like that particular year to just fine-tune my craft. I found the best way for me to learn was actually read books. And the book that I went with was Automate the Boring Stuff with Python. And I made sure I completed that book and started another book. This was called A Crash Course in Python, but I didn't get to finish that one as I figured I'd already finished the first one. Yeah, and in my fourth year, took an interest in AI and data science. That was the very beginning of of AI and data science, where we first seen the powers of convolutional neural networks and recurrent neural networks. And I thought this looks like fun. And Andrew NG sort of like convinced me to sort of like put in my eggs in this particular bucket with the self-driving cars, image detection, object detection, and NLP, of course. So at that particular time, I was actually in an internship as a software engineer at Kenya Industrial and Allied Safety Services. So this was the very beginning. I was really new, and from my time there, I learned. I really learned a lot because the people in that particular group, first of all, knew more than I did, and it was just a good place to sort of like understand what it entails to break into the workplace as a software engineer. And actually, in my fourth year, so this is like 2017. That's when I attended my first AI Kenya Data Hackathon, and this was actually my friend called Gaku. I think he's also listening in. Was like a friend who was also interested in AI and data science as well. So he sort of like, I'll say there's this data hackathon thing. Let's go try it out. And we went there. I think the very first one, we finished third. And since I think that prize was a prize of 5K or 6K or something. And I remember we sort of like divided the price, and I got 1,000 Kenyan shillings. That's approximately 10 pounds. And yeah, I was elated, to be honest. I mean, you mean I can earn money by writing code, and actually that's 1K I think paid for my Uber home. So at least, yeah, and those free pizza as well. So that sort of like got me hooked. And yeah, and I've actually attended like I think the next two. So I did 2017, 2018. I think I skipped 2019, and then went for 2020. So they actually I don't know if that has changed, Alfred, but I think you actually have a hackathon each year, sometimes two. Yeah, and in my field year, this was during the COVID lockdown. I enrolled at 10 Academy. This is a program that actually takes in like people in African kids in their final year in uni or they've just graduated and sort of like teaches them in data science. Yeah, basically gives them a bootcamp in data science, AI, ML engineering, I think Web3 as well. Yeah, and right now, yeah, and Web3. And yeah, so that's at that particular time during the lockdown where we had, I think, like maybe 4 to 6 months where we weren't attending uni or attending school. The schools were closed down. Did an academy, and then after actually finishing the program and actually graduate and finishing my coursework in the same year. So this was yes, late, I believe, no, not late, mid 2020. Yes, and yeah, I may be getting the time the years wrong. It's been I haven't really thought about that particular time frame in a while. Yeah, so I did an academy, and then after graduating an academy, I sort of took a role in the next batch. So they usually take one batch each year. That is one batch for like 3 months, and train them, as I said, in AI and Web3 and the sort. So yeah, and I think they've also moved it up. They're also doing 2 cohorts in a year. So yeah, you should look them up if you're in your final year or you just graduated. They're a good bootcamp, as you get to learn a lot and you get to experience what it means to be in the work environment. Because yeah, it's quite intensive and requires a lot, takes a lot from you, but it's worth it. And yeah, after my role there at an academy, which was a contract for a couple of months, finished that, and then did my application for jobs abroad. And yeah, got this particular, I was fortunate enough to get this particular position as an MLOps engineer at Datatonic. This was in March last year. Yes, March 2022. Yes, yeah, March 2022, and finally flew here after the visa stuff in May 2022 as well. Yeah. So yeah, this is just pictures of me at the 2020 AI Kenya's ambulance. This was me and the team that I was with during this particular hackathon. Unfortunately, we didn't get to win anything in this particular round, and yeah, I mean, but it's still worthwhile because they also you get exposed to solutions that the winners actually sort of like came up with, and you get to learn new tricks and new ways to sort of like solve data science and ML problems. So I definitely recommend you attending to the next one. And yep, so let's get into the meat of the talk. What is MLOps? So MLOps at its core is a standardization and streamlining of the machine learning lifecycle through principles borrowed from DevOps. So 2 keywords here. We have, of course, I'm sure so standardization means like a standard, having a uniform way of actually managing the machine learning life cycle. And DevOps itself is a set of principles that aim on eliminating the gap between software development and its operation. So think of the code that you have written in your script, because I don't like Jupyter notebooks, but yeah, think of the code that you've written in your script. So how do you get that particular code that you've written in your particular laptop and get it in such a way that it's easily accessible to everyone? Like, how do you get the code for Facebook actually accessible to every person who uses Facebook? Because at the end of everything, it's just a bunch of code, and that's basically DevOps. How do you bring these particular products and tools into production? And for the machine learning lifecycle, I'm assuming you at least have or have encountered a model at some place at some time in this particular in your particular journey up to here. But if you haven't, I'll delve into it a little bit deeper. So a machine learning model is it's basically like a set of mathematical functions trained on data. So this is a train bit. We have the data ETL. So of course, data. Data is anything from traffic data, spreadsheets and the sort. and data ETL is basically extract, transform, and load that particular data. And if you've done machine learning before, you know you have to get the data and then do some transformation in it and then train the model. After training the model, you have to tune it and see whether the performance it gives is good enough. And then after actually getting the model that has the performance that you want after the tuning process, you actually serve it. So serving it is actually now, this is a part where you deploy it. You put it in maybe a VM instance somewhere, and you can actually create an API around it in such a way where when you ping it, you can get the results you want, you can get the prediction you want. So for example, I'm sure you've all used a voice assistant before. Google Assistant, Alexa, yeah, and the sort. So if, for example, if you tell it a command and there's a machine learning model running behind it, and you actually want to maybe, if you tell it what song is playing, it needs to understand what you're actually asking it. If you tell it to search for something, you're actually asking it for like a result. And the serving bit is where we have the model somewhere, and you ask it for a result, and then if it gives you the result, that's serving from the model side, from Google Assistant side. And also we have the monitoring. So the monitoring is you monitor how it actually performs in production. Is it actually giving the correct predictions? Are you getting the correct, like if you say search for this particular thing, is it really searching for that particular thing or just giving you some result that is in there? And if the result, there's something called drifting, where you get a model has drifted over time because trends change, but those are nitty-gritties of the details into the actual the fine details. So you can actually get, like, let's say if you tell it search for a car, Google Assistant, show me a car. Hey Google, show me a car, and then it gives you a card. That means the model isn't really functioning as it should, and we need to change something in the backend. We need to make an iterative solution at the end and make sure that it actually gives the correct result. So that's the update part. So we have the training bit, which is data ETL, training the model and tuning it, getting the model, the best model, and then serving it, putting it into production, monitoring it, is it giving the correct result? That's inference, and actually updating it if it doesn't. Yeah, and so that's basically the machine learning life cycle. So MLOps at its core is actually doing all this practice and automating it and making sure that you don't actually have to go and do every single step by hand. And some of the components that we have in MLOps, we have the CACD component. So this is a bit of the technical bits where the CACD component, if you've ever put anything into production. So this actually means continuous integration and continuous deployment. So we actually have different environments. So think the best way, in layman's terms, think of environment as different laptops or different places where that whole pipeline is. So we have the dev. This is where developers, more than one developer, sort of like do their testing and making sure it works. So the very first bit here, the actual training and going back, testing it, seeing if it works, the actual data transformation, and seeing that the code runs as it should, that the data is being transformed as it should, happens in this particular scale, in the dev environment. So in the dev laptop in quotes. And we have, of course, the test laptop. This is where we sort of like put it into test and see if it actually performs, and it actually, so the deployment bit. So the continuous deployment is now, that's our continuous integration is mainly through this particular training part, and the continuous deployment is this particular serving part, making sure that once you've gotten the model ready, it can actually be deployed into production as seamlessly as possible. So you get that, after you've built it in dev, you have to make sure that it's going to deploy itself across pre-prod and production, and in the production environment. So you actually have to do the continuous deployment and seeing that the whole pipeline works, and taking it into production is going just to happen automatically if possibly you push code to some place. And we have this the source code repository. The source code repository, this is where you store your code. So I'm sure you guys have used GitHub before. And if you haven't, GitHub is is more of a place where, let's say, of course, if you're building software, you can't build the whole software by yourself, unless you're Linus Torvalds. That's the guy who made Linux and Git, which is actually crazy. Yeah, unless you're that guy, you actually need collaboration in your team. So think of the source code repository as a place where you and other people in your team write code, and you can actually make changes to the same file and maybe build different parts of the system. And you're going to understand that more as I go deeper into the talk. And we have the workflow orchestration component. So this is a component that basically orchestrates the whole thing. We have something called DAGs. This is a direct acyclic graphs. So these particular DAGs are, think of a graph that goes in one particular direction. So an example of a DAG, I'm going to stop sharing this and then share this particular screen. Oh, actually, that was yeah. So where were we? So we have this. I'm going to exit this and show you a DAG. So the example, this is a DAG. A DAG diagram means that it only flows in one particular way, where we have this particular component flowing to the next component and flowing to the next component. There's no way this particular component talks to any component that comes before it. Think of it as a river that only flows. If a river is, let's say, if for example, Tana River, if it goes across Machakos, I don't think it does, but if it goes across a certain city, there's no way it's going to come back to that particular city. And so that's a DAG, just basically a graph that flows in one particular direction. And so we have to orchestrate the workflow in such a way that every single step in the pipeline is in that particular DAG, where we have the first step is do the ETL, and then after the ETL, train the model, after train the model, serve the model, and etc. We have the feature store. The feature store, think of where we are going to get our features. So the features are basically the data that we transformed before. So we got some data and we changed it into a format that we'd actually want to use. So the feature store is where we actually store that particular data and retrieve it when we want to do the actual training. And of course, you have the model training infrastructure. The model training infrastructure is, you have to do this thing on the cloud. And if you use the cloud, we have VM instances, basically virtual machines on the cloud, or that's a very first bit, or we can use containers and the container orchestration tool, which is Kubernetes, shortly abbreviated as K8. So that's Kubernetes. And yeah, we have the model registry. So the model registry is where after you've trained your model, we actually want to store it. So it sort of like follows the same logic as a code, where you have a particular model that was trained by a particular set of parameters, and storing that makes you see how maybe the performance changed, how the performance of the model changed over time, and whether to, which particular model performed best. And so that you can sort of like go back to a model. If you have a model that came in a bit later, but doesn't perform as well as an earlier model. So you actually have to have a model registry. And we have the ML metadata store. So the metadata stores store the actual training, the actual training data. This is which run was this? So the name of the run, which particular parameters was used. Did you use like maybe 0.8 for the logistic regression, or how many layers you use for your convolution neural network, or something of the sort. I know that's a bit detailed. That's a bit too technical for some of the non-technical folks. And we have the model serving. This is actually, as I mentioned before, taking the model to the final customer, and how do they get data off it? And is it really streaming? Yeah, is it online inference? This is basically streaming predictions or batch inference. And then we have the final one, which is a more monitoring component. So the continuous monitoring of the model. And again, you need to see if your model actually performs as well as it does, or it doesn't, which you call model drift. Has it drifted from the initial prediction that it was making before? And what sort of predictions is it making at this particular moment? Yeah. And so this particular diagram here, I hope it's clear, is basically how a machine learning project goes from inception to actually landing in your hands. So for example, how the actual assistant was built from the brains of the business people at Google to the technology, to the software engineers at Google, and to you actually, to us, where we can say a command on the phone and it actually works as it should. So with that, we have the very first bit. This is B1. And B1 is basically where the business stakeholder sort of like identifies an issue that can be solved by AI. Let's say, let's build a virtual assistant for people, or for example, let's use ML models to sort of like predict how this particular good is going to sell at this particular instance. So that's a very fast step, B1. And the B1 step actually happens hand to hand with sort of like the data scientist and the solution architect. I think I think that sort of like has been counted. So that's a very fast place. That's above this particular stage. So the initiation of the whole project. So we have the B1. This is where we actually start thinking of the model. What particular data is it going to use? What particular model are we going to build? Which particular algorithm are we going to use? And this particular stage is mainly for the data engineers, the data scientists, and the data engineers as well. So the data engineer will define which particular data are we going to use? Where do we get it? How are we going to format it in a way that is going to fit our model? And how we're going to use it. And then the data scientist sort of like defines the features that we want, which particular columns are we going to drop, which particular information is important to us, and how do we use it? And that's where this particular step, B1, happens. And then we have the B2 step. The B2 step is where we do the data pre-processing. So as I said before, we have to transform this data that we've gotten, because in the real world, data is rarely clean. I don't know if you yourself have tried logging anything. You get that sometimes you use different formats. Sometimes you use a number, sometimes you use Roman numerals, sometimes you use basically you don't usually use a clear convention when actually creating data for yourself. And so we have to transform this particular data into a format that is going to be useful for us building the model. And that's where the feature engineering pipeline step takes in. So we connect the raw data, get the data, extract it, you get the data. Yeah, I mean, same thing. And then do the transformation and clean it. I'm sure you've done data cleaning before. Remove all the null values, remove all the empty rows, and transform those columns into a format that you guys can use. And of course, we have the feature engineering, create new features, delete columns, and the sort, and do, of course, create now the output. So this is called the data ingestion job, or batch streaming or streaming. So this is where, after you've done the pipeline, we need to store this data to the feature store where we had. How do we actually get it to this particular place? And that's where the whole pipeline. Now, this one is supposed to run automatically, where the data gets from a particular source and gets it into the feature store. And then from there we have C, and C itself is experimentation. So experimentation is data analysis. What does the data tell us? Here, this is where the data analysts sort of like come into the picture. What is the representation of the data? Let's say if, for example, we are using something like the census data. I'm sure that's something that's common. Yeah, like the census data. How many households have less than 2 children? So this is where that actually happens for the data analysis. And then the data preparation and the data validation. So the data preparation and validation is going to take the same step that we had up here, where we do the cleaning as well, and we do the dropping the null values. Let's say, for example, we have outliers in the data set. For example, we have, if you want to find out the median number of children in like a household, of course, there are some households that have like a higher amount of number of kids. So we get a household that has maybe 7 or 8 kids. That's an outlier, because that's not really the common value that you get, the average value that you get in people. So you have to know how to deal with outliers as well. And this is part of the data scientist role. And then they actually do the model training. So this is where you do which particular algorithm did you use. Are you going to use K-nets? Are you going to use logistic regression, linear regression, or a convolution neural network among other new sort of like sophisticated models? And then you do the model validation. What are the parameters? Basically, what are the best parameters to produce the best model? That's a hyperparameter tuning and everything related to the model validation. And then you actually export the model to the model registry that we talked before. And of course, the model training code. So after all this experimentation bit has been done, this is the tuning bit, training, retraining, and the tuning. We come into the now, the automated ML workflow pipeline. This is where you, as the MLOps engineer, are actually going to get into the picture. And here we have so this actually automates the whole process of data extraction from the feature store that we have. Does the same, because the things that you do in experimentation, in actually building the model, you have to do the same for actually serving the model. So the same transformations that you did up here, you're going to do the same transformations in the pipeline as well. So it's sort of like that. And you actually do the model training and the refinement. So you actually automate the model training on the new data that sort of like came in. And of course, model validation, is a performance good? And here you can actually do models, because you already have a model in the model registry. You can sort of like gauge the performance. Is this particular new model performing better than the old model? And if so, by how much? And if it does, maybe you can have like a binary switch or a if statement that says if this particular model performs better than the old model, then actually put this particular model into production and export it into the model registry. So I'm assuming you'd have different of them for serving, and actually select like the correct model. So, and then again, pick up the model from the old model that you have in the model registry, check whether this one is better than the old model. And if that condition is better, then push it to the model registry and make sure this new model is a model that you're going to use for production. So we have your export model and then push model to registry. And now you have the old model and the new model. So if something happens, if the new model really performs bad in production, you can sort of like roll back to the model that actually performed better or had a better performance. So this is where actually the MLOps role and where most of the involvement is going to be, as this is mainly a data scientist role. And this is where the data scientist does most of the work. And we have the data engineering who does the the basically data extraction pipeline. And from this, you can see you actually have to write some of these components. As I'm going to show you later, some of them actually require refactoring of this particular code. Structure this code in a way that is going to sit inside an actual pipeline. How can you run this code in, for example, a Vertex pipeline, a Vertex AI pipeline, or a Kubeflow pipeline? Those are just some tools that I'm going to shed light into a bit further. So as you can see, that the MLOps engineer role, sort of like transition across like the whole data domain, where you have to understand. You may not actually have to write the data extraction tool, know the data engineering and what happens in data engineering, but you can sort of like get a gist of what's going on, and you can be able to format that data in a way that's going to fit inside this particular pipeline, and also the data science and the data, the model building bits, like so. And of course, pushing it to registry, that's software engineering skills. So you can see we have the model development bit, ML infrastructure. This is traditional DevOps. Where do you actually put this particular model into? I know you've had, I mentioned Vertex AI and Kubeflow. Those are just some of the tools that help in this particular bit of infrastructure management. We have data engineering, which is basically getting the data, as I said before, DevOps engineering as well, and the software engineering, because you actually have to design and write good code practices. And yeah, so this is the next part where I show you what a particular pipeline looks like. From the example that I had of the DAG, yeah, so this is what an actual pipeline looks like. So we have a component. So a component is basically a container, and think of a container as I know I said an environment as a laptop, but a container is more of a stripped down version of a laptop. Think of it as basically the bare minimums. So your computer and your laptop requires an operating system and some hardware. So the very basic things that are required to actually run your computer, your operating system. So this is the kernel, the networking bits and sort of like that. So a container is basically the barest minimum you can actually get of that particular system. And so mainly they usually do a particular function. So I don't think this has any output. This doesn't have, okay, yeah, so that doesn't have artifacts. So we have, does it? ML metadata. So this actually sort of like, I have no idea why this is failing, but this is basically, this is a pod. That's just Kubernetes stuff. Okay. So yeah, it's not working as it should, but I'll show you. So this is basically what a pipeline looks like and a workflow looks like. So every single bit of this, for some reason it fails. Of course it does when you're actually doing a presentation. So this is actually a component, and this particular component does a specific function. I'm going to show you in the code where we have like a clean data function. So this actually corresponds to maybe a stage like this, where we had the data transformation and the data validation. So this particular bit where we have the data transformation and the data validation, and you can see that every single component here sort of like corresponds to the automated flow that we had before. So we have download the data, clean the data, data extract, do the extraction, clean the data, do the feature preparation, and then this is a model. I called it find the engagement and experience score, which is basically done in a model, and find the satisfaction, which is also done in the model, and the serving bit, because this fails because I didn't put it into production. I didn't have like an endpoint to actually hit, and how this actually looks. The development of this looks something. So I'm gonna share the second bit of the screen, which is the code itself. Here we go. So the way KFP, so yeah, I'm sure you can all see my screen, hopefully. The way KFP works, that's basically the standard library that you use to build a pipeline, where we have, as you can see, we have this particular function, and this is not a typical function. It should have the, I'm going to show you how it works later on at the bottom. So this is basically how you write a typical function in Python, but you're going to define it later at the bottom, where actually you can see I don't import any of these libraries in the global section. I actually do it in a particular function inside the function. So, and this means that every single component that you're going to use, or every single library that you're going to use for a particular component, has to occur inside a particular function. So we'd have, for example, you see I have import pandas here, and then since it's used in the importation and getting the data and actually exporting this to a particular path, and here I have to import pandas again to do the cleaning, and pandas again to do the feature preparation. So at the bottom, so this is also import sklearn, and the K means for clusterization, actually another function. And how you actually define the pipeline, you can see we have the domain specific pipeline. We give it a name and a description, and then you can see we have a component. So using the Kubeflow pipelines components, which we convert that particular function to a container. And this is basically what this particular function does. And you can see we specify the function that we have above. This is basically the last step. So you see this is the name, and then we convert that particular function into a container, and we specify the actual packages to install. And after that, we sort of like define the DAG, where you can see we have, after defining the actual container to run the bit that does the download data, the clean data. So we actually sort of like set them into a particular pipeline where we have step 1, download the data. So this is where you actually define the pipeline. Step 2, clean the data. Step 3, feature preparation, and blah, blah, blah. And so this is, let's say, for example, you are actually deploying it on AWS. This is on the cloud. You'd have to go some manual steps that actually include. So that's Zoom. Are we? Okay, so stop sharing, and then let me share the other screen. Yeah. There we go. So you've seen how to actually build this. And from the slides, where if you actually want to delve deeper, I've actually made some articles on how to actually set up Kubeflow locally, and how to set it up on AWS, and how to create an actual pipeline if you actually want to know how to actually build them. And if you want, I can share these slides with you, and you can actually go through this particular instructions and these particular blogs on how to actually build a component. And then for Datatonic, we have Turbo templates. So this like the first 3 articles I have here are just going to illustrate how to actually do it on AWS, as Google offers something called Vertex pipelines, which is basically does the heavy lifting. So for if you're using the Vertex pipeline itself, I'm assuming you can see this, you don't actually have to select, you don't actually have to do these particular steps. The Kubeflow on AWS, and but of course you have to do the build ML pipeline components. And this one, you can actually get it in this particular repo. And yeah, basically this is Google's offering of that particular process, where they actually do the because Kubeflow itself natively runs on Kubernetes and containers. This actually does most of that for you, and all you have to do is deploy this, which does another bit of your job. This is deploying the infrastructure. You can remember one of the components that we had here was actually the modeling infrastructure. So you actually have to deploy the code using Terraform. And so we have Terraform here. And I don't know if you've encountered Terraform, but this is basically, if you've built anything on the cloud, you usually mainly do it by clicking stuff, like going to the UI and actually saying, I want this particular model. But this sort of like does the orchestration for you. This takes away that clicky bit of it, and you can actually write code to deploy stuff. So instead of going to the to maybe Google and then saying create a bucket, you can actually write a piece of code. So for this, we have a module called buckets that creates the buckets for us. And I think if you want to either delve into the DevOps or the MLOps space, learning Terraform is a good place to start. And it's really, really, really worthwhile. So where we, yeah, the bit where we have challenges. Typically you don't, so the very first challenge that we have in MLOps is typically you don't get institution actually focusing on MLOps. Most of them actually focus on actually building the model. How do you get that? How do you clean the model, and how do you clean the data? And I'd argue the most important part of model creation is actually deploying it and putting it into production. How does it actually work, and should it work as it should? And we need more focus in those areas. And as of course, it's going to grow like MLOps, the machine learning hype might have died down, but its practicality and its need in the industry is still there. And actually learning these skills make you very marketable in the job market. The second bit of challenge is it's hard to design ML pipelines to cater for fluctuating demand. For example, you can't really gauge how the production, or for example, if you deployed something on maybe if you've deployed an app before, I'm sure you've encountered something called the load balancer. So the load balancer sort of like meets demand. It sort of like sees how much traffic, let's say, for example, in layman terms, let's say, for example, there is during the World Cup, In the World Cup, of course, the final was watched by so many people, and it had a higher viewers, a lot of viewers than any other matches usually do. So, for example, if that was online or on YouTube, you have to cater for the millions, probably billions of people actually watching the match. And no, you have to encounter and like, for example, if it's a final, or maybe Arsenal are playing Man United, and and of course that's going to gather quite a crowd, but not the same crowd as the World Cup final. And for that, you sort of like fluctuate the demand. So you'd say spin up this many instances for the World Cup, and if it's the Manchester United versus the Arsenal game, then bring that particular number of VMs down to this particular number. So for ML pipelines, it's really hard to do that. And the infrastructure that you sort of deploy in the beginning is the infrastructure that you're going to be stuck with at the end of the whole training process. And it's also hard to debug ML pipelines, as failures can be a combination of the ML infrastructure and the software. So for example, if a model isn't really serving as it should, maybe something might have broken somewhere, like some component isn't working as it should, some container isn't really working as it should, or it might be actually the model itself that has an issue. So actually doing that and figuring that out requires some nuance, and is usually hard to sort of like pick out and actually solve. But the trends, as I said before, we have MLOps is increasing in demand as the machine learning stack is maturing. This means that most of the times, like the models, sometimes the companies outsource the machine learning, like the actual building of the model and the model creation, and they get data scientists from outside, come work their data, and actually get that particular data into production. So MLOps itself is a growing field, as these particular models built by everybody have to get into production. Nobody's going to build their model and then say, go around announcing I have a really good model at home, where it's not actually doing something. So actually bringing that model into production is a very valuable skill set. And the maturity and standardization of tools is improving. So for example, we have the Vertex AI. That's Google's offering of how to do the AI pipelines. And that tool it still has some bugs, of course, but it shows that we are a step in the right direction, and more tools are going to become available, and a standard is going to be set soon, where we have like every single company is using a certain set of tools that actually bring value and bring models into production. And yeah, so for breaking into MLOps, I'm sure that's maybe why most of you guys are here. So you actually require software engineering skills. Again, learning to code is a very, very valuable skill. Basically, if you can write code, you are to some extent very good at problem solving, because most of it is basically debugging your code and finding errors in your code and how do you actually fix them. So you actually have to have concrete software engineering skills, and learn them and be proficient at one particular language. Learn one particular language really, really well. And then after learning one language pretty well, then you can actually divert and move to other languages, and also have some cloud experience. So cloud experience is AWS, GCP, and Azure. So if sometimes these things are actually hard to get, because the AWS build, like for example, the pipeline that I have is running on AWS, and I actually started it yesterday evening, and today after the talk, I'm going to look at the bill and be like, oh my god. But some of these things are actually expensive. But GCP has a $300 credit, where you can actually use its services until that particular $300 limit is reached, and you can use as many emails as you want. You just have to change your debit card information, your bank account, and your details that you give them. And AWS doesn't offer like an actual free tier, but it doesn't offer like actual credits, but you can get some free tiers where you get if you use a particular sort of VM instance, you don't actually pay for it. I haven't used Azure before, so my knowledge of that is really limited. And you also have to have experience with Docker and Kubernetes. Like I think most of the things nowadays, most of the things into production are run with Docker or Kubernetes. So you get that Google has an offering called Cloud Functions and Cloud Run. This basically run on containers, but XA itself runs on Kubernetes and Docker. Excuse me. And we get even Lambda itself runs with it on Docker and Kubernetes. So yeah, having experience with Docker and Kubernetes is also something that is very, very valuable and a very valuable skill set to have. And of course, a good understanding of Linux. Like once I turned to Linux, I said no to Windows. And yeah, I'm a huge fan of Linux. I think it's very intuitive for a developer, and it actually some of the Linux instances usually break and in ways that you wouldn't expect, and it actually forces you to sort of like learn and understand Linux commands to actually use your machine. And I think the best way to learn is via actually facing problems and actually fixing them. And for the distro, I'd recommend, I'm a Fedora boy, and Fedora all the way. So a good understanding of Linux, and if you have the capacity and the capability, a Mac also runs on Unix, so that's also a good system to have, as it's basically the same commands as Linux, and of course a good knowledge of the ML frameworks, Keras, TensorFlow, PyTorch, sklearn. But that's mainly for model building. Again, you don't have to have like a very concrete understanding of deep down of how everything works. You just have to know what goes where and how to actually build a model and the different ways of actually building a model. Yeah. So conclusion finally. So MLOps is a multidisciplinary practice where you get that it involves many multiple practices, from ML itself, software and data engineering, to effectively deliver value from ML models. So without these particular backgrounds and with basically no understanding of these particular practices, it's very hard to actually deliver value from a machine learning model. And having that particular understanding is very concrete and very, very crucial to how you actually break into the field. So that's me, Alfred. I don't know if I've missed anything or if we have any questions. So I don't know how we're going to facilitate that.
Yeah, so first of all, thank you very much for that very good session. Quite a lot of things to unpack from that, and I hope people have picked some insight from that will guide them in this path of breaking into MLOps. So if I head over to Slido, we have quite a number of questions for you. The first one was people asking whether they should start with AI or ML. So I'll just let you handle that first.
I didn't quite get the last bit of that particular question. Could you please repeat it?
So someone asked whether they should start with AI or ML.
So AI and ML are basically the same thing. So I know the traditional sense AI is the convolution neural networks, the recurrent neural networks, and ML is the sklearn model. So basically the regressions, and the sort, but basically both are the same thing. And I think you'd actually, if you actually want to delve into the convolution neural networks and the recurrent neural networks, starting at ML is a good place to start, because you actually understand like the best ways of actually what's it called? Validation of a model. How is your model performing? And getting that intuition from ML itself is important as well, because it also appears in the AI bit, where you actually have to find how your convolution neural network is performing, and you actually have to understand things like true positive and true positive, recall, precision, and that particular bunch. And for software, for ML itself also has you're actually even sort of like deepening your intuition into ML and AI, and actually learning how to actually write that particular piece of code. and that particular transition will be helpful in the long run when you actually get to AI, if you actually do that at that particular time.
Okay.
Okay, that answer that particular question.
The next question, they're asking whether the slide can be made available to them. I believe we'll do that. So Kevin will share the link to the slides with me, and then I'll put it both on the Facebook page and also on the Meetup page, and I'll just send it to everyone who registered for the event. So that one is covered. The next question is from Sheila. She's asking, how do you navigate around when you want to change careers? So let's say you're in electrical and electronics engineering and you want to transition to AI and ML.
Personally, I think if you're actually passionate about it and you actually want to do it, then do it. You just have to, as I said, like this particular stack. So you actually have to start with the software engineering skill. That's always sort of like the base where you actually have to know how to write code. And I think that's a very fast step if you actually want to transition from an engineering heavy discipline to the coding discipline. And if you're doing electrical and electronic engineering, that's triple-E. I'm sure you're very good at problem solving and you have the tenacity to actually do software engineering. So that leap isn't supposed to be that big. But yeah, just if you feel like you want to do it, then go for it. I have a friend also from Kenya. We met in London. He also did triple-E and sort of like transitioned into not really the AI space, but into coding. But it's basically the same thing. Just pick up a book and say you want to write code and go for it, and then start from there. Start from the actual basics of writing the code, and you'll get there, I believe. If you just have to keep your head down, work hard, and if you have the goal in mind, go for it, and you'll achieve it, I believe.
Okay, next question. Someone is asking, what code editor are you using? And which one is the best for ML?
The code editor is actually like up to you. You decide what you want to use. Some people are like usually prefer working on the terminal. So the Vimfox, Emacs, and Nano. But for me, I use VS Code. And yeah, let me do a shameless plug. So for VS Code, so I particularly use
VS Code paying you to share this.
No, I haven't even got into the shameless plug part. So this is VM Code, and it runs my own theme. And if you actually install VS Code, you can go to the extensions, and I think you can search. This is basically, I don't know if it's going to show up. This is basically my coding tag, and you can find this particular theme. This is my theme, and you can actually download it and use it. So yeah, VS Code is a good place to start, and has a lot of functionality. As you can see, you can integrate it with Docker, SQL tools, Git tools. You can actually integrate it with your music player and see how much you actually listen to music while you're coding. The coding that you actually use helps you debug, and helps, of course, with GitHub and Git integration. Or you can see which particular file changed, and you can do merge with it. So it's apart from the plug, it's a very, very good text editor.
Okay.
And it's not necessarily for ML only. There's no like one text editor for one particular thing. It's universal. You can use it for anything. So feel free to use it for any particular coding solution or coding problem you have.
Okay. The next question is around, how did you land your job abroad?
So that's a really, really long process. But as I'm sure most of you know, for the non-Kenyans, we have something called Tamakin, and Tamakin basically implies you know how the tarmac is. That's basically a road where you know what tarmac is. Yeah. So tarmacing is actually going from office to office with your CV, actually tarmacing and walking on the tarmac to deliver your CV from one place to another. So that particular bit is there, I believe, for everybody every single person who gets to a place where they actually have to get a job without connections. And even with connections, you actually have to tarmac a bit. And that was the same for me. First of all, job search is always a numbers game. So the more position you apply to, the higher chances you actually have to get. And you actually have to figure out which particular roles you want and which particular positions you're targeting. And having that goal in mind is very, very, very crucial, as you know what you want. So for me, I was mainly looking for remote roles at the beginning, and then I found out that if a job hasn't been written remote, that doesn't mean it's not going to sponsor you, and it's not going to visa sponsor. So you actually have to get a sponsorship to get a visa and move to the country that the job is in. So don't say you won't apply for a job because it doesn't have the word remote in it. So you just apply for a job, and if you're good enough and practice and apply to as many jobs as you can, and make sure that the jobs that you are applying to fit your particular skill set. Don't go applying for something that is completely unrelated and think that you're going to actually learn that particular role. So you actually even have to be smart with it. Apply as many as you can, and in the meantime, just develop your skills and level up your skills to a place where anybody can see value from your particular skill set. And build projects as well. I think projects are actual very, very important. So after you've done most of this, make sure you can build a project. Let's say a project that does a particular task, and that's going to go a long way, and put that in your CV. But it's also a process. You have to get your CV right, apply to as many jobs as you can, and learn how to market yourself as well. So yeah, I hope that in a broad sense, like for the sake of the time, I couldn't really get into the details as much, but that's basically all it entails. Yeah. Hopefully that's enough answer. If it's not, maybe you can add another question in the chat, I believe.
I think you've really answered it well. Just keep trying, and I mean, don't get discouraged by, you don't need to meet all the qualifications of a job, as long as you're really passionate about it and you've set your eyes that you want to go there. Just give it a try. You never know what happens. And also one very important point you've mentioned is the project. So I see lots of people, even after they finish an ML course, most of them still don't have projects that they've really packaged well. So you still need to put some effort in trying out a project that will clearly bring out the skills that you've learned in the course, or the skills that you've picked up, even as you're self-learning. So that's one very important thing. Thank you for that. And
to add a little bit, there's a quote that I can't remember where I picked it from.
Yeah,
it goes like, don't reject yourself. Let them reject you. Don't be like, oh, I don't meet all the requirements. Of course, be smart about it, but don't go like, oh, I don't meet all the requirements, so I won't apply. They're probably going to reject me. No. You apply. Let them reject you. And if they reject you, it's not really you they're rejecting. You just have to be okay with rejection, because that's going to come. But don't let them reject you. Do not reject yourself. Let them reject you. So that's basically it.
Okay, thank you for that. The next question is, in terms of math and data science knowledge for ML, which courses or resources do you recommend?
Math for ML. So for me, in the very, very beginning, like as I said, in my third year, what I did was I went for Andrew Ng's course on ML engineering and AI, and that was mainly done in MATLAB. And luckily, I had encountered MATLAB before in JQuat, which is, I mean, I had learned it a bit. So that's actually, and the best part about MATLAB is it's not really an actual programming language that you can actually write code in and actually build stuff in. Yes, you can, but it's not really that intuitive, but it's mainly a mathematical and a computational language where most of its applications are in doing very complicated math. And that actually gave the understanding of that particular math, but that's for an AI sense. If not, I think because most of ML is statistics, I think just having a good foundation in statistics and understanding some of the loss functions goes a long way. in understanding that particular math.
Thank you for that. The next question is around ChatGPT, which is very interesting. What are your thoughts around ChatGPT, like its impact in the field? Will it take people's jobs? And I can also add a layer to it. So in your daily role as an MLOps engineer, how do you think advances like ChatGPT will impact it, or just generally generative AI?
Yeah, I think first of all, ChatGPT is very impressive. Training something that it's not perfect. That's a beautiful thing of it, and that's the beauty of it. It's not yet perfect, so you don't have to worry about your jobs yet. Keyword on yet. So, but it's so good. It can actually write very good articles that you can't even tell have been written by an AI. And I think we're going to see this grow even more into the future. It's crazy to predict where the future is going to be, but I expect crazier things as models are just getting crazy and really good. Like ChatGPT is practically good, but I don't think it's ready yet to replace our jobs. And I don't think the people at ChatGPT are actually writing it to replace us. Plus, it's the reason why it's so far from taking our jobs as well. It's not capable of critical thinking. Like if I don't know if you've seen the snippet where ChatGPT has been asked. John's mother has 4 children. Kyle, Mark, and James. What's the name of the other child? We all know, of course, it's John. It's in the title. But you see ChatGPT says there's not enough information in this particular question to answer that particular prompt. So it's not yet there, but it's really good. And in my day-to-day life as an MLOps engineer, I don't know how many of you have used GitHub Copilot. So GitHub Copilot it's also offered in VS Code, or did. Like I ran out of the of the particular trial period, but now you have to pay for it. But it basically predicts the next line of code. So for example, it was writing import this particular library. It'd say import pandas, and then it's going to offer predictive tests, like how you write predictive text on your mobile phone. You have let's meet and then at this particular in Gmail. So it would say import pandas as PD, and then the next line would be import numpy as NP. And that's like one of the ways where I use generative model in my day-to-day. It's just something that makes writing boiler code pretty easy. But since the trial period ended, I haven't really been using it that much, but I think it's free for students. So that's also something to look out for in the space to watch.
Okay. The next question is on ML and the medical field. So what would you tell someone who wants to dive into combining ML and medical equipment, and will it be safe for patients?
So ML in the medical sense is actually a very tricky field. First of all, because of the data, but if you have the data, then well and good. Some of the data is really hard to find, because I know an ML model is only as good as the data that you have. That being the first caveat. The second caveat is you really can't make mistakes in a medical field. Like let's say you have a model that predicts a person has cancer, and then this particular model has a false positive, where a person doesn't have cancer, but the model says this particular person has cancer. That's a life that you've potentially harmed. That is for that particular person himself and the people that are supported by them. So it's really such a very high risk area, and you have to be very careful about delving into ML in the medical space. But then again, we have offerings that are sort of like tailored with a practitioner. I think there were some models that I think were really good in the X-ray field, where you get a model could identify somebody who was going to get a heart attack earlier than a doctor or something. Like I can't really remember the details, but I know sometimes it's spectacular. So just know it's just know that if you get a prediction wrong, it's going to, you just basically can't get a prediction wrong. If you do, the consequences are way, way, way dire. And that's such a high bar, sort of like breakthrough and sort of like get into the field, unless it's not diagnosis and it's maybe a form of like getting an ambulance, the quickest way to a particular person. Like, for example, get the nearest ambulance to a person who's sick in the nearest place, unless it's something that aids the receiving of care to a particular patient. But if it's diagnosis and saying something is wrong with the patient, you have to be very careful, and the bar is so high. And it's a very hard ask to actually do that.
Okay. The other question is around the development environment. So for the local environment, is Jupyter Notebooks the best, or are there better ones used professionally? Is it better to host on Google Colab or GitHub? Yeah.
Okay. I don't exactly what you mean by hosting on Google Colab, but for me, I'm at core, I'm a software engineer, and the first thought of a Jupyter Notebook is like, no, don't do that. But Jupyter Notebooks are really, really, really good for sort of like prototyping and actually, like building products that sort of like have a quick feedback loop. For example, if you actually have to build a model, you can actually do everything in one particular Jupyter Notebook, and then you can see the results of that particular model there and then. But if you're writing a script for like a model, you'd have to find inputs to that particular model, actually wait for the whole script to run for you to get a particular value. So Jupyter is very, very good for prototyping. And really, I think all offerings are the same. Like Colab is the same as just the Jupyter Notebook that you have in your particular machine, and it's also similar to Vertex Workbench. And for the issue, for where you say that having using GitHub or Colab, I'm assuming you meant where you store your Jupyter Notebooks. And for me, that's just an easy question. Just use GitHub, as GitHub is, first of all, teaches you how to use GitHub and teaches you how to use Git. And Git is sort of a must-have skill for a developer in working in an enterprise or working for an organization. If you've done all of this and you don't have Git experience, learn Git. Like, I think, I should have Git inside here. Git is a must-have skill for anybody in a development or a software engineering role, or wishing to delve into a software engineering or a code writing role. So GitHub rather than Colab, and mainly use Jupyter Notebooks for prototyping and actually doing that iterative model building on that particular space.
Okay. The other question is for proficient DevOps stroke ML engineer who is looking to break into ML and studying full-time. How long would it take on average to be proficient in ML? I guess they're just trying to know how long does it take to be proficient as a DevOps or ML engineer?
For me, there's this meme where there's a guy climbing a mountain, like sort of like an iceberg, and somebody is learning. So this guy is going up the particular that particular iceberg, and then he gets to a place where he thinks he knows a lot about actually writing code. And once you get to that particular point, you'll know that you don't know a lot. There's way much more to learn. So being an expert an expert at one particular field is going to take a lot of years, and actually being an expert is going to take so many years. And proficiency really depends on you. First of all, how quickly do you learn How quickly do you pick up skills? How good are your problem solving skills? How much effort are you putting into it? How many hours are you putting into that particular task? And for sometimes, as you said, you're still studying, and as you said, you're a DevOps. So I'm guessing you're working and studying at the same time, which also takes a huge chunk of your time. But yeah, I think if you can still manage it, then you'd have to manage your time really, really well and put in the effort. And it really depends on who you are as a person, how long that's going to take you. It might take an year, might take 2, might take 3, might take. I don't think it can take a couple of months. And even at that one particular year, I think you're still sort of like scratching the surface, because even I know I still have loads and loads to learn, because it's a really big field and it's ever changing. So you also have to keep up with new trends and read new papers and such. So it really depends on the person. But I don't think it's such an easy answer as a year or 2. You can be good, but to be really, really good, it's going to take a substantial amount of time.
Okay, then I think just rounding up, the last question is whether you are a member of IEEE, and if so, how did it benefit you? So I don't know if someone listening associated you with that group, but you can just comment on that.
IEEE. Forgive me for I forgot most of my acronyms from school, and I'm not pretty sure what that is. But I don't know. Maybe if they can clarify, maybe shoot a quick comment over there and clarify what that particular is, because I can't recall what that is.
Yeah. So the IEEE is the Institute of Electrical and Electronic Engineers. It's a global body for students and professionals who are working around or are learning the field of electric and electronic engineering. However, if you don't know about it, I think they need to do a bit of work.
But to be fair, I haven't really used most of my engineering skills, that like my actual engineering skills in quotes, like the actual electrical engineering skills I learned, the power engineering skills I learned in uni. So but I think as long as you're learning, I think the best thing you can do for yourself is first of all, don't pardon my French, don't bullshit yourself. So make sure that whichever field that you are in, you're actually doing the best that you can in that particular field, and you're learning and you're growing. Always seek to learn and grow. And if IEEE allows you to get those particular that first of all, the exposure, and then that particular field and place to sort of like grow and learn and actually develop your skills as an engineer, I think then go for it. As long as you're learning and growing, you're in the right place.
Okay. I guess they were just trying to, they're in particular, communities or bodies, so they're just trying to see whether where they are is sort of the right path, or whether they're in the right group that I guess would lead them somewhere.
If that's the case, I can't really answer that question for you. You know what you're doing there. Like, for example, with AI Kenya, I went back for more because I knew what I was getting from that particular situation, that particular exposure of writing code. So it actually depends on you with IEEE. You actually know what you're getting from that, and if you find that valuable for you, then well and good. I can't come and tell you that it's not. But if you yourself think it's not valuable, then why are you even doing it? Move to something that you're going to enjoy and something that you think is going to be valuable for you.
Okay. Thank you so much. I guess that's all the questions we had today. And thank you for, just taking your time to speak to the community. I have to apologize. We had a few technical hitches today with YouTube, but at least it's good. Zoom also supports Facebook, so we just quickly switched there. I'll share this event recording with everyone who had registered for the event, so that they can still watch it and perhaps also ask any questions, follow-up questions that they have. I can also maybe also just share your either Twitter handle or LinkedIn, where people can also reach out to you in case they have any further questions.
I mean, I do have a Twitter, but I'm not really active. I'm not a huge social media guy, but I do have a LinkedIn, and yeah, maybe I can share the link with you, and you can share it together with this particular recording. And I'm happy to answer your questions on LinkedIn. Just I might not reply immediately, but once I get the chance, I'll definitely reply. And yeah, just bear with me if I don't reply immediately.
Okay, good. So thank you so much, Kevin. Just allow me to close the event by just sharing one or two announcements. So I'll just stop your screen and share my screen here.
Just so I can give you the final thought, then thank you for having me, Kenya. That was a nice presentation. I enjoyed it. I also enjoyed the questions. Those were very, very good questions asked. And I also thank you guys for attending, for the support. Because if you guys didn't attend, that all of this would have been
Two people chatting.
A waste of my time. Yeah, but thank you all for attending, and I appreciate that.
Yeah, thank you so much. So I'd like to let everyone know, in case you want to speak on a particular topic and share your knowledge and experience the same way Kevin has done today, you can apply as a speaker on our website, www.kenya.ai/mentorship. So we have an engage section where you can select the different ways you want to participate, send us an email, and then we'll review your application and then get back to you. So make sure you do that in case you're interested. We'll keep having monthly events. So our next event will be, of course, next month in February, late February. It will be a guest lecture by myself. I'll be talking a bit on entrepreneurship in AI. So please check out our meetup page, and our social media pages will be sharing details on that. Otherwise, thank you so much for joining us today. Keep building, keep learning, and keep sharing with everyone. Kevin, thank you for your time today.
Yeah, thank you for having me.
Yeah, have a good day, man.
Yeah, you too.
Okay.
Yes.
Bye.